The last but not the least is referring to the refractive index and the speed. We can have the sign of all the wavelengths, rather. Let's compare wavelength and speed. So we can have V1 over V2 equal to lambda 1 over lambda 2. This is wavelength. This is the speed. So if we take the ratio of the two, equate them, then we are still dealing with what? The refractive index. This, we're going to be applying them when we are solving problem on this. So next is other still the formulas that is involved when you are dealing with waves. So if you are dealing with, if you want to get the power of a lens, what do? All you need to do is to find the inverse of the focal length. If you are given the focal length as 3 cm, for example, if I need the power of the lens, I will just do 1 over 3. Now let's get to sound wave. Sound wave, what comes to your mind once sound is talked about in physics? You will remember the concept of echo. What is echo? Echo is the sound heard after the reflection of sound. That tells you, before you can hear the sound will need to travel and then reflect back. That is, the distance is going to be twice. Unlike the ordinary speed we do talk about. Speed is distance over time. But once you are discussing the concept of echo, the distance will have to be twice. That's why you are having that 2 there. V equals 2x all over t. The 2 there shows that we are dealing with echo. And the question will always be clear about that. Okay, the next one is beat frequency. What do we mean when we talk about beat frequency? When you are giving 2 sounds, for example, of different beats, that's of different frequency. Finding the difference between the 2 frequencies gives you what we call beat frequency. It's actually easy to pass JAMB because these are the applications that you'll be seeing. So assuming we have a note coming from a piano of about 50 Hz, and we have another piano giving you about 52 Hz. If I am looking for the beat frequency, all I need to do is to subtract 50 from 52. So 52 minus 50 will definitely give me 2. That's 2 Hz. The unit of frequency is Hertz. So take note. The velocity of sound is directly proportional to the square root of temperature. Somebody will ask, how comes about that? That's why when you shout, for example, in the morning time, the sensation will be different from that of the night. I told you that you are going to be applying all this. We're going to see questions that will revolve around this today. But for the sake of our calculation, if you say that speed is directly proportional to the square root of the temperature, that tells you can, in case you are varying 2 quantities, V1 over V2 can also be said to be equal to the square root of T1 all over T2. Take note, your temperature must be measured in Kelvin. That's where you're going to have issues. And how do you do that? If you are giving in degrees Celsius, all you need to do is to add up 273 to that, and that will be in Kelvin. So in case the square root here will cause lots of trouble, all you need to do is to remove the square root and use it on this. That will now be V1 squared all over V2 squared. That will give me T1 all over T2. I think this is pretty okay because most of you are always afraid once you see the square root sign. So let's turn it the other way. So that will square the speed, V1 squared over V2 squared equal to T1. Take note, your temperature must be in the standard unit, which is Kelvin. So the speed of light is 3 multiplied by 10 raised to the power of 8 meters per second. That will bring up a question, for example. Why is it that lightning is always seen before a thunder? I told you, you must know how to apply all the topics. If not, you're going to have nothing less than, let's assume 30 to 40% of calculation, and the rest is going to be theoretical question, which will tax your brain on the concept of the topics that we're going to be treating. So why is it that you will see lightning before thunder is heard, whereas the activity takes place at the same time? Because the answer will be what? Based on the speed. The speed of light is greater than that of sound. Lightning is seen before thunder because speed of light is greater than the speed of sound. What's the speed of sound? Speed of sound is around 330 to 340 meters per second. Compare that to 3 times 10 raised to the power of 8. That is a whole lot. That tells you definitely see light before thunder overhead. So let's go to the other part of the board. And we are talking about string and open pipe. That's the application that we are looking at now. String, open pipe, then closed pipe. That's vibration. So we'll not have the whole time to explain how the whole thing generates. But you all know from your elementary knowledge that once you trouble your string, something happens and you'll be having this type of loop. You have the first one, then you have the second one, and so on and so forth. The first one is referred to as the fundamental frequency. Second one is called, which is also called the first harmonics. The second one is called the second harmonics, which is called the first overtone. So now what is the fundamental frequency of a string, which happens to be the same thing as that of the open pipe? It is given as V over 2L. All we need to do in this class is know how to apply them, not how to generate the formula for now. So F0, which is fundamental frequency, is equal to what? V over 2L. The L stands for the length, the V stands for the speed. Now, if I need the next frequency, what do? I don't need to generate it from the board here, because in string and open pipe, we notice that there is a what? A progression in the frequency. And it is sequential in nature. That is from 1 to 2, from 2 to 3, and so on. So, looking at the board now, F1 will be twice of F0. You see what we have there? So, I don't need to cram anything here. All I need to know is the fundamental note or frequency of a string, which is V over 2L. So, if you ask me to find F9, what will I do? I will simply add 1 to the 9, and then it will become what? 10 F0. Already I know my F0 to be V over 2L. So I will have 10 F0. By the time we apply it, you will see how it goes. And don't forget, the application of string and sonometer and an open pipe can be seen under the concept of sonometer. Your sonometer is an instrument to study the frequency of string. And in doing that, you will arrive at that formula you have there, which we are going to use to solve problem possibly later. So there you have your F0 in sonometer as 1 over 2L root T over N. I'm rewriting this because I want to explain something here. That's where student often makes mistake. What is the M standing for? What comes to your mind is just mass. But please, it's not just the mass you know. It is mass per unit length. If you are given the mass as 2 kg, and the length is 3 cm, or meters rather. Okay, let me take the mass as, let's take it as 15 kg. That tells you this guy will become what? 15 by 3, which will be what? Which will be 5. We're going to make use of 5 here. Not just what? 15. It is said to be mass per unit length. What is T standing for? We call it tension. Tension is definitely force on the string, which is measured in what? In newtons. And your L is the length, F0. What happens here, F1, F2, F3 also happen in sonometer. So if I need F5, I'll simply do what? 6 multiplied by F0. And my F0 is already known from here. So let's move to closed pipe. This one is a bit different from what happened in open pipe. So it moves in odd form. The other one is sequential, but this one is odd in nature. That is, if you have 1, the next number you should be thinking of is 3. After 3, what you have what? 5, and so on and so forth. So, but the F0 here is V over 4L. I'll be doing something real quick on the board here to explain that. So, for F0, that's for string, it's V over 2L. But, which is the same thing for closed pipe. But, that's open pipe, sorry. But for closed pipe, F0 is V over 4L. So let me write. Closed pipe, open pipe. You must get this gist, if not you apply it wrongly. So for this, it moves sequentially. That is, F1 will become what? Twice of what? F0. But here, it's not the case. F1 cannot just be twice of F0. That is not true. Because I told you it's moving what? In what? In odd form. That's why I'm giving you a formula that we have out here, where we have fx is equal to what? 2x plus 1 f naught. This is all you need to know, and you are safe. Assuming I ask you to find what? F5, which is the fifth overtone. I'll just substitute 5 into the x. That's what? 2 by 5 plus what? 1. So what do you have there? 10 plus 1, that is 11. Definitely I have 11 f naught, making the 11 odd. Because I told you in closed pipe, you have odd as what? As what? The prefix of the f naught. So take note of that. If I need f7, what do? I'll just multiply 7 by 2. Okay? And I'll have what? I'll have 14 plus 1. Then that's 15 f naught. Lastly, if I need f15, what will I do? That's 15 times 2. That's 30 plus 1. And I have what? That is 31 f naught. Giving you odd values before your f naught. But take note of f naught for each of them. F naught for string, an open pipe, and then f naught for closed pipe. And if you have a resonance tube, what is a resonance tube? It's just a simple instrument for studying the what? The sound in a pipe. Okay? It's a closed pipe though, and if in doing that, you're going to arrive at what I have on the board. V equal to 2L, open brackets, L2 minus L1. I hope we have, a wonderful time going through this. All we need to do next is to look at the basic questions that will possibly follow all what we have treated so far. But before then, I remember telling us that you must know the facts that guides every concept in physics if you must pass it. So let me give us some of the facts before I move into the question. Have you ever thought of why you go around and you don't see people painting their cars black? Have you ever asked yourself that question? Why? Because we are in tropic region and here it's very hot. So if you have a car painted black, definitely you're going to attract more heat. And then you're going to give, if your car is having an AC though, you're going to give the AC more work to do. So it attracts heat more. You are going to see those kind of questions. Let me give you another one, for example. It's possible you see a man in a swimming pool and then the legs may appear very short, whereas that's not the original length of the what? Of the leg. What comes to your mind? That is concept of refraction, because when light falls on it, it bends, and then the legs will now appear what? Short. Now let me talk about another concept, for example. Have you ever asked yourself that crystalline structures are not observable in other states of matter aside solids? Those are questions that should be rolling through your mind. We'll be back soon. Stay tuned.